Math 1332, Chapter 3, Symbolic Logic, Section 2, Truth Tables, Video 8, Truth Table Example 3, Two Simple Statements. This will be the final video in this series, focusing on two simple statements. The next three videos will be with three simple statements, and the tables will get larger. But for this one, we're going to construct a truth table for the compound statement P biconditional, open parentheses, negation P and Q. Or with smaller words, P if and only if, not P and Q. All right, so we're going to attack it the same way we did before. You'll notice that I've already got a truth table started with the columns for the simple statements P and Q and all of their possible truth values. Let's go ahead and determine the correct order. As usual, and even if I forget to say it, you are always welcome to pause the video and attempt to answer a question before I do. It's actually better to try that when you think you have the idea, because one of two things will happen. You'll get it right and reinforce your own confidence in being able to construct truth tables, or you'll make a mistake, and as you watch the table worked out on my end, you'll see where your mistakes are. It's okay to make mistakes. People make them all the time. What's not okay is to not learn from them. If you never try one on your own, you will never know the mistakes you're making, much more learn from them. So I always encourage you, anytime I'm about to work an example, if you think you can work it in advance, pause the video, work it out, compare it to the worked out solution, and either pat yourself on the back for doing a good job or make notice of the mistakes that you make and make notes of why you made them and how to prevent making them in the future. All right, so if you haven't done so already, go ahead and pause the video and try this one. And I'm about to start working out now in 3, 2, 1. All right, so what do we do first? We analyze the compound statement using the hierarchy of connectives to determine the correct order in which to build our table. On the top of the hierarchy are parentheses, which we have, so we need to look inside of there first. Inside of that parentheses is a conjunction and a negation. And according to the hierarchy, which one takes precedence? The negation. We're going to do the negation first. That does not conclude the content of the parentheses, so we have to stay inside the parentheses with the only other remaining connective is the conjunction. So we will do that second. That does complete the parentheses, so we look outside it for any more negations or connectives. And the only connective outside the parentheses is the biconditional, so we will do that one last. Not because it's on the bottom of the hierarchy, but because it's outside the parentheses. All right, now that we have identified the correct order in which to build the columns in our truth table, let's build the columns in our truth table. The first column is going to be built on the negation that is in front of the P. That will conclude the negation, so we close that column. That was supposed to be a line. Okay. The second in our order is the conjunction. On the left of the conjunction is a negation P. Well, it's a P, but the P has a negation on it. On the right of the conjunction is a Q. That's our second column. So let's close it off. And then our third and final connective / negation is the biconditional, which has a P on the left of it. And on the right of it, a parentheses, so we bring that parentheses and its contents. That is what we will do third. There are our three columns. And now we populate them. Now, if you weren't sure how to get started, but now that you see the columns populated, you think you can tackle it, go ahead and pause the video and try to fill out all three columns from left to right. I am going to fill them out here in 3, 2, 1. Our first column is for negation. So, what is the rule for negation? Negation changes the truth value. So we need to change the truth value. That's what we are going to do. But which column are we going to do it to? The same column that represents whatever follows the negation. What follows the negation is the P, so we are going to apply that rule to that column. Since there's a column in the way, let's cover it up real quick. And now let's do our rule to our column. We are going to change the truth value on this column over here and write it in the first column. The P column is true, true, false, false. And if we change those truth values, we get false, false, true, true. There's the first column. Let's clean this up. Moving to the second column, what connective was the second column built around? It was built around this conjunction, which means we need the rule for conjunction. And what is the rule for conjunction? The rule for conjunction, true only if all t's. So that's the rule we're going to apply. Where are we going to apply that rule? To which previous columns? To the left of the conjunction is the negation P, which is this column. To the right of the conjunction is Q, which is this column. Although there are no columns in the way, I am going to go ahead and cover up the P column because we don't need it right now. I guess I can cover up this one too just for a second. And now we're going to play out the rule on the correct columns. In other words, we're going to populate this column by applying the rule to these two columns. So we are looking for things that follow the rule. The rule is T only if all T's. Are there any rows where there are all trues? This row. That is the only row that is all trues. So that is the only row where the current column is going to be true. Since none of the other rows follow that rule, none of the other rows will be true in this column, which means that they will all be false. There's that column. Let's clean everything up. And let's move to the last column. Which connective was the last column built on? The last column was built on the biconditional, which means we need to play out the rule for the biconditional. What's the rule for biconditional? Biconditional is true only if both halves have the same truth value, which is like saying it's true only if both halves match. So that's the rule that we're going to do. But which previous columns are we going to apply it to? To the left of the biconditional is a P, which is clear over here. To the right of the biconditional is this parentheses, and its contents is negation P and Q, which is the column that we just populated. Since the two columns that we're going to focus on have a bunch of stuff in between, let's cover up what's in between for a minute so that it's not in the way. And we're going to apply the rule to this column and this column to populate our final column. So, are there any rows where both halves have the same truth value? In the first row, do these have the same truth value? No. In the second row, do these? No. In the third row, do these? No. In the fourth row, do these? Yes. The fourth row is the only row where the two columns have the same truth values, which means the fourth row is the only row where our biconditional is true. It's false in the remaining rows. Let's clean this up. And there we have the completed truth table. If your only concern is completing the truth table, you're welcome to stop watching the video. But you know me, love the follow-up questions. So here's my follow-up question. Does that last column resemble the last column of any of our basic truth tables? Meaning the truth table for conjunction, disjunction, conditional, or biconditional. It does not. But do you notice something? It's the complete opposite of one of them that we do have. Just for a moment, let's pretend that we take the negation of everything. Does that look familiar? That is the truth table for P disjunction Q. So if we took the negation of P disjunction Q, it would match. So this guy is not equivalent to any of our basic truth tables, it's not equivalent to any of our connectives on their own, but it is equivalent to the negation of one of them. Interesting.